the eigenstates corresponding to eigenvalues E1 and E2 of a time-independent Hamiltonian are 1 and 2 respectively. Now, if at t is equal to 0, the system is in state given here. The value of this bracket evaluated at time t will be what? So, first let's write out the so this is the value of the wave function at t is equal to 0. So, at t is equal to 0, the value of the wave function is sin theta 1 plus cos theta 2. Now, this is the given, this is what is given to us. Now, to find the value at t, at a value t, we have to include the time dependence. Okay, we have to include the time dependence to both the wave functions. So, the time dependent term is the exponential term. So, we'll include the time dependence. So this is the time dependent term, e to the power minus I e e1 by h bar multiplied by t. So this is the time dependence term. So this comes from the solution of the time dependent part of the Hamiltonian. Plus cos theta, this is theta. So again, here also we add the time dependent term. Now we have to take essentially what is the dot product of these two. So psi of t and psi of t. So this is something like your dot product in vectors. So this is in Hilbert space. So this is like something like a dot product. So psi, we have 1 and 2. We treat the states 1 and 2. We'll treat like two states I and j in your vector space. So they are like orthonormal basis. So what we'll do is now when we dot it, so we just multiply them out. So we multiply them out and we'll have cross terms. So first we'll get the square term, sine square. So when you multiply both, you get sine square, and sine square first you get the so when you multiply with its complex conjugate. So if this is psi of t, this psi of t is nothing but the complex conjugate. Okay, so therefore this exponential term will go off. Okay, so that's why this exponential term goes off. Then you just collect all the, then you let's write out the second square term. The second square term is cos square theta and then we have all the cross terms. So remember, so if this is psi of t. This psi of t is the complex conjugate. So when you're multiplying them both together, sin theta, cos theta, e to the power I. So notice what I said between, just like I had drawn a comparison between I and j. So I dot I. So this is I. This bracket I said is like your dot product. So this bracket I said is like your dot product. So I dot I is nothing but 1, right? So I dot I is nothing but 1. However, I dot j is nothing but 0. So similarly, 2 and 1 will become 0. 1 and 2 will also become 0. This will become 1. This will also become 1. So this answer is nothing but sine square theta plus cos square theta, which is nothing but 1 itself. So the right answer to this question is the option A.